So guys, looking at tangents again, and this time we're going to be moving on to something that uses the information you'd have done previously. So in the previous page there, and in some previous practice questions, you would have worked with one single point outside the curve and drawing a tangent from a point external. This time around, we are faced with a question where we have two circles given, and the tangents that we need to draw are external, in this case external to both. So for these two circles here, you'll have a tangent that touches on top of both curves and at the bottom of both curves. And once again, we can't just guess and draw the lines. We can't just lay the set square in and join the dots roughly where you think it should be. We need to do this with a method and with accuracy. So what we're going to do is, this is it, okay? Little rule, okay? They've said, given the two circles, construct an exterior tangent. If the tangent is outside, the radius goes inside. And on the next page, you'll see that if the tangent is, I'll just put this in brackets, if the tangent is inside, the radius goes out. So T out or in. Tangent outside, radius inside. T in or out. If the tangent is inside, and inside just means crossing inside, touching perfectly onto both, just like that. If the tangent is inside, we take the radius outside. Right, what does that mean? That means that for circle number 1 and circle number 2, if the tangent is outside, we take a radius in. What I do is this. I'll draw a blue line here. Random line now. I'm going to subtract the small radius from the big. Okay? So I'll subtract the radius of the small circle from the big circle. So I'll take the exact radius there of the small circle. That's exactly set now to the radius of the small, and I'll subtract it in from the big. Lots of people do this wrong. They take the small circle and they just end up redrawing it here. Okay? Instead of redrawing the exact same small circle, which doesn't really make any sense to the question, we take the radius and we subtract it from the big. So I've now stepped in R2, the radius of circle 2 right there. And that has just set up for me a brand new question. And that new question has a new radius. So I'm going to draw that circle. And I'll explain what I've actually done here in a sec. We've changed that question from something hard to something very easy. So I'm going to set up this new question now. And the new question is in orange. And it goes from point P to the orange circle. That is the new question. What we have done is this. We have taken both circles and we have shrunk them down by the same amount. We've shrunk them down by 17 millimeters, which is the radius of this. We shrink both circles until one circle becomes a point and until the other circle just becomes smaller. So you just shrink both. And once we change that question into this new one, where we have an orange circle here and an orange point here, we can use the exact same principle, same method as we would have in previous pages to find the tangent from the orange point to the orange circle. Once we have that tangent done, we open it back up again. So we collapse it for a while, find the small tangents, open it back up and find the big ones. That's the plan. Let's do it. What's our method was, join the center point, join point P to the center, and bisect that blue line that crosses through there. Bisect that. And From that bisect position, open up to the centre of the circle, swing up and down. And that gets me the position of two construction tangents. I'll put them in here in the light green colour. They are two construction tangents from the points of contact that I just found down to this point here. What we'll find is that they are parallel to the outside correct tangents. What I mean is if I can take the angle of that green and bring it down, it's going to be the exact external tangent as well. But there's one more step along the way, okay? And this is that one last step. I'm going to join. I have a tangent drawn there, and now if I join into the center point, I get the normal. Okay, that gets me a step closer. And if I keep that normal going out till it hits the circle, I have expanded the question back out again to what it was. And if I take my sliding set squares finally, because that's one point of contact there, if I take my sliding set squares and slide across at the same angle, I get my 2 points of contact. And I get my POC here, and that gives me my correct tangent. There's a POC on one side, there's a POC on the other. Same thing up top. I join and draw my normal first of all. So from the point there into the center, and I'll expand it up in line with that. And take that angle, sliding set squares across, and draw it here. And those two parallel normals give me a POC here and a POC here, which I can then join up and that's the question answered. So from the point of contact above and below. So what did I do? I took the question, I reduced one circle into a point and reduced the second circle by the same radius. That gave me my new orange question, which is a point in the circle. I joined the centres, bisected, drew my arc, got my green tangents, and then using the red normals here, joining from the centre point out through that point of contact and keeping going. I'm going parallel. So this guy here is parallel, this one here. This tangent is parallel, this tangent. So by exploding it out again into the full one, I get my correct answer. There's two more questions. I'll get this one started just so that you know where to go, and then you're going to go on ahead and do the last one on your own. So for this one here, if the tangent is outside, the radius goes inside. To begin, I'll draw a completely random line, any radius line at all. On this, we'll take the radius of the smaller circle and subtract it from the big one. There's the radius of the small circle, take it and subtract it from the big one. Once I have that, I can draw the new question. And my new question is from the orange point to the orange circle. I've taken the radius of circle number 2 here, and I've stepped it in there. That's R2. We'll join the center point of one circle to point P. We'll bisect. Bisect meaning split it into two perfectly equal parts. And we use the compass to do that. from that bisect position, we open up to the centre of the orange circle. There's going to be one at the right and one at the left. I'll end up actually doing the whole question here, so I suppose why not? I'll draw my tangents to this constructed one, which is, as I had in the last one, it's the orange one here. I'll draw my two tangents to those positions, and then I'm going to have to bring it back out again to make it into the full question. So I'll draw the normal from the centre point through the point of contact and extend it on out. And I'll slide down and draw that same normal down here. That gets me a POC and a POC. And we can join the dots in the POCs. On the left, I'm going to join from the centre through the point of contact and out. And sliding down, and from the next centre, we go parallel to that normal. We have our POC and POC. Now I ended up doing the whole thing. The last one is all your own. Take the radius. Take the radius, this guy here. Subtract it from this one. Now there's a little extra here that I will actually just get you started with. Show all construction lines and points of contact. Hint, you must first find the centre of the circle C. How do we find the centre of a circle? So if I just take a blank page and just lay it on over this here. How do you find the centre of a circle? Let's just take that as the circle right there. I don't know how accurate this is now. My tape might not be a perfect example, but it's the first circle I can see near me. How do I find the centre of a circle when I'm not given it? Well, we bisect any two chords. So this isn't new for you now. Draw any chord anywhere at all in the circle in one position and draw an alternate one. So you have two chords there. Bisect those chords using the compass. So set it to more than half of the orange line. So I have more than half the orange line. I join my arcs at both sides, and that orange one right there is at 90 degrees or perpendicular, and it goes through the centre of the circle someplace. Now if I could be lucky enough that my arcs there hit the centre. I don't know, that might happen and it might not. To bisect your second chord then, go to one end of the green line. Don't mix up your arcs here, don't mix up what ones you're supposed to be hitting into what ones. So that's just a little bonus construction that they've dropped into this question. And I bisect that green one with this green line here. From that point to that point. And that is the centre of the circle. So that's an extra little construction you're going to have to drop in. That's revision. We did that a few weeks back. And yeah, that's about it. You're going to use that construction first of all to find the centre of circle C, and then you're going to use this main construction we've worked on here for the last two. That's it for this video. Best of luck with the drawing.